Hello, my name is Ricardo Suarez. I'm a Principal Advocate at AWS, and in this session I'm going to talk to you about accelerating digital transformation with hybrid capabilities. Today, businesses across all segments, all sizes and every geography are driving digital transformation by moving to the cloud. They do this to increase agility by using modern application approaches to reduce the time to market, to leverage services such as AI and ML and IoT to build innovative new services, and to be able to scale up and scale down to meet customer demands. Businesses also look to reduce the complexity and risk by simplification and transparency that moving to a pay-as-you-go model brings. Many enterprises are challenged by the fact they have to maintain existing, often large and complex legacy systems. They are seeing falling budgets, and the budgets they have are often monopolised by operational spend, dealing with things such as security threats, vulnerabilities, or increases in market regulation. A large portion of resources are being devoted to maintaining systems to keep up with the business, rather than to help it move faster. And they're left without the necessary resources to support critical business initiatives that are required to maintain competitive advantage. The traditional IT model often lacks the agility you need to keep up with pace of innovative startups. And so whilst enterprises look to provide these new capabilities to the business, they also need to keep in mind the existing workloads and how to optimize those and take advantage of the new capabilities that cloud brings. When we asked customers what they were looking for, customers told us they want the ability to integrate on-premise resources with cloud resources. They do not want to have to rip out and start again, and they wanted an easy way of doing this. Organizations are moving their workloads to the cloud as quickly as they can, and whilst most applications can be easily migrated to the cloud, some applications may need to be re-architected and modernized before they can be moved. And some applications may need to remain on-premises due to low latency or data sovereignty requirements. Hybrid cloud architecture is the integration of on-premise resources with cloud resources. For most organizations with on-premise technology investments, operating in a hybrid architecture is a necessary part of cloud adoption. Migrating legacy IT systems takes time. Therefore, selecting a cloud provider that can help you implement a thoughtful hybrid strategy without requiring costly new investments in on-premises hardware or software is important to simplify operations and more easily achieve your transformation objectives. Regardless of where those workloads may reside, organizations want to be able to develop once and be able to deploy those workloads on cloud or on premises in an agile and consistent fashion, using a consistent set of APIs to manage and operate. Furthermore, enterprises need to be able to leverage investments in skills, technology, and processes across those environments. This leads many enterprises to seek hybrid cloud architectures to integrate their on-premise and cloud operations to support a broad spectrum of use cases, from data center extensions to VMware cloud migrations to building and managing applications using a common set of cloud services and APIs across their on-premises and cloud environments. Customers want a hybrid architecture to support their transformation, and this is supported by market data. By working closely with enterprises, AWS has developed the industry's broadest set of hybrid capabilities across storage, networking, security, application deployment, management tools, and application integration to make it easy for you to integrate the cloud as a seamless and secure extension of your existing investments. We have also created strategic partnerships with long-time leaders in on-premises platform providers such as VMware, Intel, Microsoft, and SAP, that allow you to run your existing enterprise applications on AWS with full support and at high performance. AWS is the best cloud for hybrid because it offers the broadest and deepest set of services to address the broad spectrum of hybrid use cases. AWS provides the best solutions for VMware workloads, brings the same AWS infrastructure and services on premises for applications with low latency or local data processing requirements, provides a large and more reliable global footprint than any other cloud provider to help customers meet their strict reliability and global coverage requirements, and provides the best hybrid solutions to store, process, and analyze data for disconnected or poorly connected environments. When we look at how customers are using hybrid capabilities to achieve digital transformation, we do see some recurring patterns. Customers may need to increase capacity but have no available resources within their data center. They might want to selectively move workloads such as development or test. They might want to rapidly increase and then decrease capacity to meet either planned or unplanned events. And perhaps they want to expand into different geographic locations quickly. They might want to optimize, innovate, and add disaster recovery and backup capabilities, take advantage of advanced security capabilities to improve security whilst minimizing changes to applications, or enhance availability and resiliency of critical applications and workloads. Migrations to the cloud that might be triggered by large-scale events such as data center closures, data center evacuations, mergers and acquisitions, or perhaps the need to facilitate data center refreshes while keeping those workloads running. Finally, they want to take advantage of AWS services and application integration capabilities so they can experiment, innovate, and modernize their applications as well as create the next generation applications. So let's take a look at some of these hybrid capabilities in more technical detail, starting with the hybrid capabilities for customers who are running VMware workloads. AWS is VMware's primary and preferred cloud partner, and our partnership with VMware has yielded several industry-first hybrid solutions. The first is VMware Cloud on AWS, or sometimes VMC, which provides customers some great capabilities for seamlessly migrate and extend their on-premises VMware vSphere environments to the AWS cloud. VMC is a jointly engineered service between AWS and VMware, and is the only VMware hybrid cloud solution that is directly managed and supported by VMware. VMware Cloud on AWS is available globally, and we have jointly engineered over 200 features with VMware since it launched. Another jointly engineered hybrid solution is Amazon RDS on VMware. Amazon RDS on VMware lets you deploy managed databases in an on-premises VMware environment using the same Amazon RDS technology enjoyed by hundreds of thousands of AWS cloud customers. And finally, we have AWS Outposts, which allows you to deploy the very same hardware that you would find in the AWS regions, but within your own data center. So let's take a quick look at what the VMware Cloud on AWS architecture looks like. Software-defined data center, or SDDC, is an on-demand cloud service that allows you to provision from 0 to workload ready in 90 minutes, adding host capacity in 12. It is managed by VMware, which means they take care of patching, updating, and upgrades, and provides you with cluster sizes from 3 hosts up to 16, and allows you to configure 10 clusters per SDDC. You can take advantage of Elastic DRS, or Distributed Resource Scheduler, to automatically scale up and scale down those clusters based on utilization. This is used, for example, to automatically remove failing hardware and bring in new hardware into the cluster without you having to manage it. Customers can either bring existing AWS accounts that they have or create new ones. And integration with AWS is via high bandwidth and low latency connectivity, with customers having the ability to manage that connectivity. For example, you may want to limit the traffic from your VMware workloads to AWS services such as Amazon S3, and for that traffic not to leave your private network. You can also use your existing internet connectivity to integrate with VMware Cloud on AWS. You can use services such as AWS Direct Connect with or without VPN, which provides more predictable network performance and is useful for those critical workload migrations. An HCX, or hybrid cloud extension, provides seamless integration and workload mobility between your on-premises vSphere environments and VMware Cloud on AWS, which means that you can migrate your workloads with 0 downtime. You can deploy your clusters into multiple availability zones, or AZs, to provide greater availability in what's called a stretch cluster. You will not need to make any changes to your applications, and with AZ availability treated as a VMware high availability event, and VMs being started in the other AZ. And we provide 99.99% SLAs for these stretch clusters. You can use VMware Site Recovery Manager, or SRM, to provide customers with new ways of designing disaster recovery solutions that remove the need for dedicated DR data centers and provide application-centric DR capabilities. And you're able to protect multiple sites with a single VMware Cloud on AWS SDDC to reduce your operational complexity and cost. All the data in VMware Cloud on AWS is encrypted by default using AWS Key Management Service, or KMS, across your environments, and this integrates with VMware SAN volume encryption, allowing customers to have a seamless and centralized control over your encryption keys. VMware Cloud on AWS uses bare metal Amazon EC2 instances under the covers, providing customers with a choice when provisioning their VMC environments. For general purpose workloads and clusters, you can use the i3 metal instances, But if you need clusters with more storage, then you can use R5 metal instances. And these use Amazon Elastic Block Storage to increase storage capacity. VMware Cloud on AWS is certified against many certifications and is GDPR ready. As customers move workloads to VMC, we see many modernizing those workloads and taking advantage of the integration with AWS services. And as you can see on the screen, there are some common patterns and AWS services that are used. For example, customers who are migrating Microsoft SQL Server will often use services such as Amazon Directory Server to provide authentication. They might use Amazon S3 as a backup target for SQL Server backups, or use AWS CloudWatch to provide monitoring and health metrics on instances. Now, Amazon RDS on VMware allows customers to, provides customers with an easy solution to set up, operate, and scale relational databases. Amazon RDS on VMware automates database provisioning, operating system and database patching, backup, point-in-time restore, storage and compute scaling, instance health monitoring, and failover. Now, we see customers using Amazon RDS in a number of different use cases, from enabling low-cost, high-availability hybrid deployments, to database disaster recovery to AWS, to read replica bursting to Amazon RDS in the cloud, and long-term database archival using Amazon S3. If we take a look at the architecture, Amazon RDS on VMware uses the RDS connector with software appliances that are deployed in your VMware vSphere environment. With the RDS connector, you can manage on-premises relational database instances through a dedicated VPN tunnel from the AWS region. This allows the control plane from Amazon RDS to stay within the AWS cloud in the region. Amazon RDS provisions and manages database instances on the on-premises VMware environment through local components that are deployed on your VMware vSphere environment during setup, and these make up your local control plane. These components deploy as virtual appliances. The edge router that is deployed into your vEnvironment cluster is used to route from the AWS cloud to your vCenter server. This appliance also runs DNS and DHCP services for cluster control network, but it also manages the VPN tunnel that connects your on-premises environment with the AWS cloud. The RDS connector executes data management operations on-premises, and a number of other control VMs perform functions such as storing Amazon RDS metadata, snapshot and object store management, event processing and aggregation to monitor the health of systems and trigger events as needed, and the integration with vCenter operations. Customers that have invested in VMware Horizon 7 virtual desktops can now leverage VMware Cloud on AWS to scale those environments out and provide additional capacity that can be very useful in situations where you have an unexpected need to support large numbers of virtual workers. Stagecoach is a leading public transport company in the UK that runs over 11,000 trains and buses and transports over 3 million passengers a day. And they wanted to implement a cloud-first directive and needed a platform that would provide speed, agility, scale, and resiliency for mission-critical applications whilst maintaining operational consistency. By using VMware Cloud on AWS, they were able to migrate mission-critical applications from on-premises to cloud and leverage native AWS services. Okay, so now let's move on to AWS Outposts and how you can run native AWS services from within your own data center. Many customers have standardized on AWS services and APIs to build their applications in the cloud, and they want to extend that model to applications that remain on-premises for latency or local processing requirements. AWS Outposts allows you to deploy the very same hardware that you would find in AWS regions within your own data center. This is not different architecture or different hardware platform. And if you were to open one of these servers, you'd find the same Nitro cards that we use in our own servers. It is a fully integrated and managed offering, which means we take care of monitoring, updating, patching, and all the operational aspects of this service. But it appears within the normal AWS console experience as another resource that you can use. So why did customers ask us to make this service? Customers have told us that some of their business critical applications are sensitive to latency and variability in latency. They need applications to run on-premises to respond to events with extremely small millisecond latencies, and in order to ensure smooth and predictable operations, to provide a superior experience to end users and to maintain a competitive advantage. They also tell us that they've got and are seeing an exponential increase in the data that's being generated by users and by end devices, and that data integrity is a key concern in locations that were bandwidth constrained. They have data-intensive workloads that collect and process hundreds of terabytes of data a day. Transmission of this large volume of data to the cloud is wasteful and expensive. And transmitting messages or data streams over long-distance internet connections can also lead to packet loss, resulting in data integrity problems. If we take a closer look at what the Outposts look like, you will see that it is an industry-standard 40 TU rack that, when fully assembled, is ready to be rolled into final position. It is installed by AWS and is simply plugged into the power and network. Now, some of the features you can see from the screenshot are the centralized redundant conversion unit and DC distribution for high reliability and energy efficiency, as well as easier serviceability, as well as other redundant components such as the top-of-rack switches and hot spare hosts. Now, one thing that you will need to be aware of is there is an updated shared responsibility model for AWS Outposts. And whilst AWS is responsible for protecting the Outpost infrastructure similar to the existing one, customers are responsible for securing their applications as well as the physical security of the Outpost. This does mean that AWS services that are launched locally will go through a separate evaluation and certification, and the existing ones will not apply. Customers own the responsibility for the physical security and access controls around the Outpost for compliance certification. Outpost is available in two variants: native AWS, which is generally available, and VMware Cloud on AWS, which is currently in beta. The native variant of Outposts allows you to use the same APIs and control plane that you use in AWS Cloud to build and run your applications, but do it on-premise. The VMware variant allows you to run VMware Cloud on AWS locally on Outposts, to use the same VMware control plane and APIs that you use on your own premises infrastructure. This variant delivers the entire VMware software-defined data center, compute, storage, and networking infrastructure to run on-premises using Outposts that allow you to take advantage of ease of management and integration with AWS services. If we look at the services that are currently available on the AWS Outpost 2 users, you will see we have our compute services such as EC2 and container services such as ECS and EKS, and storage in the way of Elastic Block Storage and Amazon Elastic MapReduce. There is a preview of Amazon RDS that supports MySQL and Postgres, and this provides you with the capability for low-cost disaster recovery, read replica bursting to Amazon RDS in the cloud, or for long-term archival. And coming soon in 2020, you'll be able to store data using the Amazon S3 API. And this will allow you to store data locally to meet local processing requires, or to allow you to do and meet lower latency processing needs. AWS Outposts are powered by the same Intel Xeon processing technology that you have on-premises or in the cloud, providing you with a consistent infrastructure, consistent application performance, and making it easier for you to migrate your applications on AWS Outposts to AWS. You can run a variety of different EC2 instances to suit the use case you have, from general purpose computing to compute intensive, or memory intensive and IO intensive workloads. You can have the same local instance storage and EBS GP2 volumes for temporary or permanent storage. Now, as well as that, all Amazon tools will work. API calls will automatically be logged, for example, in CloudTrail. Existing CloudFormation templates will also work. And AWS tools such as CloudFormation, CloudWatch, and others can be used to run and manage applications running on premises in just the same way as you would for cloud workloads today. As well as that, you will have the same security controls such as IAM permissions, VPC security groups, and access control lists. Customers can seamlessly extend their VPC on-premises by creating a subnet and associating it with an outpost, just as they associate subnets with an availability zone in the cloud today. As the control plane is in the public region, they can access a wide range of AWS services locally on their outposts, or in region through public endpoints or privately through VPN. Instances in the Outpost can securely talk to other instances in your VPC through private IP addresses. Interface endpoints powered by Private Link provide access to all regional AWS services such as Amazon S3 or DynamoDB in your private VPC environment, or you can use regional public endpoints as well. You're able to connect AWS Outposts to your own local network via ports that are provided in the top-of-rack switch. You'll need to configure these virtual interfaces using the Link Aggregation Control Protocol, but once you've done this, a new option within the AWS console called the Local Gateway will allow you to route traffic to and from your local networks. Now, for both AWS Outposts and VMware Cloud on AWS, the AWS Partner Network of technology and consulting partners are validating technology solutions, helping customers with integration of these as part of their hybrid architecture, as well as providing consulting services to help modernize and migrate. Now let's look at application integration capabilities for creating hybrid applications. AWS offers a broad set of integration services that allows you to leverage existing investments in technology while creating modern applications and innovating using AWS services. Whether it's using AWS Glue to crawl and ingest data from existing sources, or create data lakes, or create rich application integrations by leveraging Amazon EventBridge, you will find the tools needed to integrate your existing cloud workloads. Many customers are building data lakes, but need a hybrid architecture and capabilities that allow them to collect data from data sources inside the existing organization data center, as well as the new ones they have in the cloud. The example architecture you can see here uses AWS Glue in a hybrid environment that uses JDBC connections and using Elastic Network Interfaces, ENIs, in an Amazon Virtual Private Cloud, VPC. The ENIs in the VPC help connect to on-premises databases over either a Virtual Private Network VPN or using services such as AWS Direct Connect. And this allows AWS Glue to crawl data sources from both existing AWS data sources running either in installed services or using managed services such as Amazon RDS, which are the orange arrows, or using data sources that you have in your own data centers. These are the blue arrows. Many customers use and love open source technologies. Open source provides hybrid capabilities, allowing customers to make choices based on the level of flexibility and customization they want, the skills and resources they have, or the level of the risk they want to take on. And they can use and run existing self-managed versions of open source technologies, or look to use AWS managed versions of those. Using services such as DMS, Database Migration Service, customers can also move off proprietary database platforms and move on to open source database versions such as Amazon RDS, MySQL and Postgres. Amazon Athena Federated Query allows you to build connectors to your existing data sources and build federated queries. These connectors are open sourced, allowing you to quickly use and extend connectors available or build connectors to any application or data source that you have within your own hybrid environment. And when creating new modern applications or performing data analytics, you can then leverage all your existing data sources. Societe Generale serves 31 million customers across 67 countries and is one of the largest banks in Europe. When building their SG Markets customer-facing portal, they used AWS services to gather data from different internal data sources before enriching them and delivering them both to internal and external customers. Now, when building your hybrid architecture, connectivity is a foundational service and you'll need to have a broad set of capabilities. You will need hybrid capabilities that will work across all your organizational physical locations, whether that's in your main office, data center, regional offices, remote manufacturing locations, or disconnected or poorly connected remote environments. Connecting those sites requires different approaches, but also requires solutions that work and scale to support the most demanding and largest organizations. You can also leverage AWS services that are provided as part of partner solutions, many of which you'll find in the AWS Marketplace. Now, Virtual Private Gateways allows you to connect your environments to AWS using secure VPN technology and extends your network to AWS via a Virtual Private Cloud or VPC. This allows you to securely access resources from within those VPCs from within your own network. You can also leverage VPN connections directly from your AWS instances using Amazon EC2 VPN instances, and you can find many partner solutions available that do this in the marketplace. Now, for clients, you can use AWS Client VPN solution that enables you to securely connect your users to AWS or on-premise networks. Now, doing this at scale and meeting the needs of enterprise customers requires some additional capabilities. AWS Direct Connect lets you establish dedicated network connections between your network and one of the AWS Direct Connect locations, and uses industry-standard networking to do this. This approach can provide a more consistent network performance when accessing AWS services and can also help you reduce your bandwidth costs. For customers that have set up many VPCs or have many remote offices, AWS Transit Gateway simplifies how you manage all your VPCs, supports integration with AWS Direct Connect, and also provides new capabilities such as multicast networking. Now, AWS Site-to-Site VPN enables you to securely connect your on-premise network or branch offices to your AWS environments. And these are often configured to access AWS via site-to-site VPNs over ISPs, which may lead to inconsistent performance or those applications running applications running on branch offices. AWS Accelerated Site-to-Site VPN allows you now to terminate your VPN to the nearest edge location. We have 200 of these globally, and then route that over the AWS Global Network backbone, as well as leveraging other services like Global Accelerated to improve the experience. Many customers have operations in remote and disconnected environments such as mines, ships, and windmills, where they store data but lack the resources to process and act on that data in a timely manner. Now, whilst AWS Outposts are designed for locations with a consistent and reliable network connection, services such as AWS Snowball Edge and AWS IoT Greengrass are designed for infrequent or disconnected environments. AWS Snowball Edge enables customers to use AWS compute and storage capabilities to collect, store, and pre-process data before transferring it to AWS for durable retention and more advanced analysis. With support for Amazon EC2 on Snowball Edge, customers can run machine learning models and sophisticated analytics rapidly, enabling faster decision-making in harsh field environments. And with AWS IoT Greengrass, this can seamlessly extend AWS to edge devices so they can act locally on the data they generate while still using the cloud for management, analytics, and durable storage. AWS IoT Greengrass connected devices can use Lambda, Docker, or both, execute predictions based on machine learning models, keep device data in sync, and communicate with other devices securely, even when they're not connected to the internet. When Deutsche Telekom started to build their hybrid architecture, they needed to automate and scale the provision of multiple AWS environments with specific hybrid connectivity, whilst ensuring they met rigorous privacy and security standards they maintained. And they were able to do this using a number of AWS services to build out that hybrid capability, using things such as AWS landing zones and services such as AWS Direct Connect and AWS Transit Gateway, as well as VPCs, which allowed them to meet all their security and standards requirements while being able to make use of the full range of AWS capabilities when developing internal applications. AWS offers the broadest and deepest set of hybrid capabilities that customers can use to accelerate digital transformation initiatives, allowing them to be more responsive and move faster as businesses and create innovative new products and services to take advantage of AWS services, whilst getting the most out of their existing technology investments. Thank you for your time, and I hope this session has been useful in helping you to understand what some of those hybrid capabilities are.